Hello everyone and good morning, good afternoon or good evening. It depends on what time you're viewing this video right now. And today I will be discussing to you a very basic topic which is converting fractions into binary numbers. So let's start. So how do you convert fractions into binary numbers? So there are four basic steps that you need to take in order to convert fractions into binary numbers. So the very first step is to convert the fraction into a decimal number. Then second is to convert the left-hand side digits of the decimal into binary. And third is to convert the right-hand side digits into binary. And the very last step is to combine the two, which is very easy because you're just going to connect the two numbers that you converted. So let's go to step one. So the very first step is to convert the fraction into decimal. So this is very easy. So I have given an example. You can see at the screen, which is we have a 29 over 4 fraction. So, hmm, wait, let me take my pen. Let's go. Um, so we have a number here, a fraction here, which is 29 over 4. So to convert this fraction into a into a decimal number, it's very easy. You just need to divide the numerator by the denominator. So that's 29 divided by 4. You can just use a calculator to make things easier. It's everywhere nowadays. I won't be discussing in this tutorial how to convert fractions into decimal manually because that's going to take a lot of time and there are tons of tutorials out there that you can just watch. I'll just link one in the description. So if you convert 29 over 4 into a decimal number, you're going to get 7.25, and this is going to be our decimal number that we're going to convert into a binary number. So let's go to the step number 2. So before we proceed to our next step, which is converting the left-handmost digit into a binary digit, we just first to familiarize ourselves with the series of numbers called the powers of 2. So what exactly is the powers of 2? I'm going to show you a series of number here, and this series of numbers is what you call the powers of 2. So how do you get this kind of series of numbers? So by the way, I wrote it from right to left, as you can see here. I wrote it from right to left just to make things simpler, because when we convert our decimal number, we are going to write it from right to left. So how do you get this um, series of numbers? So basically, if you take 2 and you raise it by the power of 0, you are going to end up with the number 1. And if you take 2 again and you raise it by the number 1, you're going to end up with number 2, because 2 times 2 multiplied by 1 is just 2. But if you take 2 and you raise it by the number 2, 2 times 2 is just 4. And if you keep doing that, if you keep increasing the exponent by 2, oh no, if you keep increasing the exponent by the increment of 1, you are going to end up with this series of numbers. So for example, if you raise 2 again by the power of 3, you're going to end up with the number 8. And if you keep doing that to the fourth power, you get 16, and 2 to the fifth power is just 32. And this, my friends, is what you call the powers of 2. This is a very simple topic. You just keep increasing the power of 2, and you're going to end up with this kind of pattern. So we are going to proceed now in our next step, which is converting a whole number into a binary number. So let's proceed. So in our second step is we are going to convert our left handmost digit into a binary number. So how are we going to do that? So on our first step, we converted our fraction, which is 29 over 4, into a decimal number first. And now we ended up with the number 7.25. So on our second step, we need to convert our whole number on the left side first to know its, and we need to know its binary equivalent. So let's write 7 here. And now here's when our series of numbers, the powers of 2 series of numbers, comes in handy. So we're going to take that again, and here we have it. So first, the very first rule on converting a whole number into a binary number is you need to find the highest base number that is less than your number in which you want to convert into a binary. So in our case, we have 7. So in this series of numbers, which one is the nearest to our number 7 but is less than the number 7? So we have here our number 4. So we are going to subtract 7 by 4. So 7 minus 4 is 3. So we have 3. And now we are going to subtract 3 by the nearest number to it, but is less than our number 3. So in our series of numbers, the nearest but less than 3 is the number 2. So we are going to subtract 3 minus 2. So 3 minus 2 is just 1. And now we ended up with the number 1. But in our case, we don't have any numbers that is less than 1. So we're just going to leave it But we're going to need the number 1. So here's the catch now. So if you add 4, so if you add these 3 numbers, 4 to 1, so 4 plus 2 plus 1, you're going to end up with the number 7. So in your series of numbers, the numbers that you subtracted your whole number with, you're going to write a 1 on it, and on those numbers that you did not subtract on your whole number, you're going to write a 0. But you are always going to start with the number that you began with. So in our case, we started subtracting the number 4 with. So we are going to write a number 1 on our 4. We're just going to write the numbers 1 and zeros because binary is just base 2. So, and we also use the number 2 because we subtracted 3 minus 2. So we're going to write 1 there. And we're also going to write a 1 above our 1 on our series of numbers. So here, my friends, is your binary equivalent of the number 7. So 7 in binary is just 1 1 1. So to make things clearer, we are going to have another example. So here we have our series of numbers again, and we are going to convert a certain whole number and turn it into a binary number. So hurry. Let's think of a number. Let's use number 75. So we are going to convert the number 75 into a binary number. So as I've said earlier, the first rule is you need to find the highest base number that is less than the number that you want to convert into a binary number. So in our case, we have 75. So what is the nearest number to our number 75 but is less than it? So the nearest number to our number 75 is 64. So we are going to subtract 75 by 64. So 75 minus 64 is, let me use my calculator. So 75 minus 64. So we have 11. So 75 minus 64 is 11. So now we have 11. And now we are going to find the number that is near. We're going to find the nearest number to 11, but it's less than it. So in our series of numbers, we have 8. So we have 8 here. So we are going to write 11 minus 8. So 11 minus 8 is 3. There you go. So what is the number nearest to 3? We have 2. So there you go. So 3 minus 2 is 1. And now we have 1 as our final number. So you can't find anything that is less than, sorry about the laggy camera, I'm sorry. So you can find a number in our series of numbers that is, oh no, I think my camera crashed. Oh no. Wait, let me fix that. Oh no, there you go, we're back. So you can find a number that is less, that is near than 1, that is near on our number 1. So we're just going to use 1. There you go. So by solving or by converting our whole number 75 and converting it into a binary number, we use the numbers 64. So we're going to write 1 above our numbers in this table to find its equivalent. So we're going to write 1 here. We're also going to write 1 here because we used 8. We subtracted 8, right? You remember? So also we used 2. And also we ended up with the number 1. So here's the catch. So let me center that first. So here's the catch. On our series, we see 1, we see 4 ones. Now there are numbers in between that we did not use. So in that case, we are going to write zeros above it. 0 on our number 4 because we did not use it. 0 above our 16 because we did not use it. And 0 also above 60. 0 also above 32 because we did not use it. And now we ended up with the numbers. Oh no, let me make it more clear. So we ended up with the numbers 1, 0, 0, 1, 0, 1, 1. So this is the equivalent, or this is 75 in binary. So 75 is equal to 1001011 in binary. So that is how you convert a whole number into a binary number. And also don't forget, you are only going to start writing your numbers from right to left. That's how you do it. It just makes things easier. And also, if the highest number you subtracted your whole number with, for example, we have 128 and 256 and 512. If the number you're trying to subtract, or if the number you are trying to convert into a binary number is less than 128, you're not going to include these higher numbers. You're only going to start the numbers that is less than less than 75. So that is the number you want to convert into a binary. So that concludes our first step. So let's go to the third step, which is converting the rightmost part, the rightmost digit into a binary. So let's proceed to our next step. On our third step, we are going to convert our right hand side digit of our decimal number and turn it into a binary number. So converting decimal numbers on the right hand side is kind of different from converting just the whole number from the left side, which we convert on our previous step. So the very first step is to take this, our decimal number, which is 0.25. So 0.25. Let me just write that down first. So in this step, we need to multiply our binary on our decimal number by 2 until we reach the number 0. So if we multiply 0.25 by 2, 0.25 times 2, oh, 2 is just let me use my calculator just to make sure. So where is my point 11, 0.25 times, here's my times 2, so we have 0 0.5. So 0.5 times 2 is 0 0.5. So, and just to make things clear, let me just put a column here. So here we go, and let's put another column here because we need this. So here, there you go. So 0.25 times 2 is 0 0.5. So here's the catch. So if you see if the coefficient has a leading number which is greater than which is greater than just being a 0, you are going to put 1 on this side, and this side is going to be our binary numbers. So binary side, let me just put the binary side just to make things clear. So in our case, we multiply 25 by 2, we ended up with 0 0.5. So our coefficient doesn't have a doesn't have a number that is greater than 0 on the left hand side. So we're just going to write 0 here. So we are going to take our left hand side, right hand side to be exact, right hand side, which is 0.5, and multiply that by 2. So 0.5 times 2, 0.5 times 2 is just 1.0. So 1.0, in this case, we have a number that is greater than 0 on our left hand side, which is here. So if you have a number that is greater than 0 on your left hand side, you are going to put 1 here. And in that case, you're going to take the right hand side here again and multiply that by 2. So 0 times 2. Let me just put that in the center just to make things clear. So 0 times 2 is just 0 itself. So because anything multiplied by 0 is just 0. And now we have met our condition. Oh, by the way, let me just put 0 here just to make things clear. So we have met our condition, which is you are only going to stop multiplying when you reach the number 0. So we have reached the number 0, and we're going to stop here. And this numbers is our binary numbers that represents the decimal 0.25. So we're going to take our so if we remember, we converted the number 7 into a binary number, which is 7 is 111, because if you check our first step, second step, you're going to know. So 7 is 111, and 0.25, we are going to copy this series of numbers. So 0, we're going to start from the top. So 0, 1, 0. So let's put a dot here. So 111.010. So this is 7.25 in binary, and that is how you solve a decimal number. No, that is how you convert a decimal number into a binary number. So thank you for watching.